Good afternoon, everyone, and welcome to the IAQ Matters online workshop, Tighten Up, the HVAC and building envelope connection. I'm your host, Troy Raszka, and I'm the marketing director for WTI Pure Air Control Services. And with me today is Steve Tratt, and he's with WTI, Canam Building Envelope Specialist, and he also is a regional sales manager now working with WTI Pure Air Control Services. Welcome, Steve.
Thanks, Troy. Thanks for having me.
Awesome. Well, I'm going to take a few seconds right off the top here to just talk housekeeping a little bit while some of our attendees are still filtering in. And so first and foremost is we have a handout tray. And in that handout tray, if you look on your go-to app and the different trays and things that you can see there, there is this slide deck as a PDF. Is in the handout tray, so you can take that with you today in case you want to refer back to it. We also have just a two-sided flat that has an overview of some of the services that we provide relative to HVAC testing, cleaning, restoration, and the like. And then we also have a really cool video that Steve provided that shows a whole building smoke test for detecting building leakage. And so I recommend that you go ahead and download that and take a look. And it's not very weighty. I think you can even do it on your phone. I didn't give you the full IMAX experience with that one. So they're all there. And then rest assured, if you have to drop off early or something, we are going to go ahead and send you a follow-up email with a link to this video of the replay of the workshop as well as the slide deck. Okay, and then the other thing that I'd ask that y'all do is that GoTo has a question tray. So I would prefer, we would prefer if you would put your questions in the question tray so that we can see it. I'm moderating the workshop today. And then that way we have time at the end and we'll answer the questions in the order that they come in and perhaps maybe the order of relevance if there's more than one of the same question, for example. So I think without further ado, we should go ahead and get started. So again, I'm Troy, and with me is Steve Tratt from WTI, and this is the IAQ Matters online workshop, Tighten Up, the HVAC and building envelope connection. And so today we are going to take a look at a range of topics, and what I do want to say is that with regard to this webinar, I think that we want to at least establish the sort of baseline of how we're going to talk and what we're going to talk about today. So obviously this is a highly technical subject, and we have invited many different kinds of folks from many different kinds of professions that have come on the webinar today. And so for that reason, and we only have 45 minutes, so I want to be respectful of everybody's time. So for that reason, we're going to keep this at a pretty even baseline level when we're talking about this stuff. We're not going to go too far into the weeds. Just know that myself and Steve and any number of our other experts at Trimco CPG are going to be available to answer questions, to follow up with you if you want to go into great detail about a specific situation or one of these specific topics. So today, what we're going to be talking about is establishing the connection of what is sort of the building envelope, the HVAC system, how they're related, and then sort of the cause and effect of the different types of air pressure that you find either being exerted onto the building envelope or within the envelope itself. Then we're going to sort of start to dive in and peel away the layers of the HVAC system. The V in HVAC, as everyone knows, ventilation. So build tight, ventilate right. And we're going to talk a little bit about the balance between these two systems, the envelope and the HVAC. We're going to just touch briefly on energy cost reduction that bringing these two areas of a building into balance can provide. And then finally, we'll wrap it up by, once we have this baseline information, what do you do to improve both of these areas within the entire building? So that being said, let's go ahead and just jump right in. So when we look at this relationship, Steve, really, what we're looking at is two parts of a larger ecosystem, right? Or a larger system that helps with building operations and helps make sure that the building is tight, energy efficient, and healthy. So the relationship between the system that's moving air through a building and the actual building envelope, that is to say, how tightly the building is sealed to be able to have these systems operate efficiently, is critical that these two things are working together to achieve the same goal. And so we know that this interaction, it can directly affect the building's health, right? The building's performance, how well the temperature is controlled in the building, what kind of pollutants or contaminants come in and out of the building, but it can also affect occupant health. And that could be a variety of different things from cognitive function to allergic reactions to even more important or critical kinds of illness that could be put in if there's mold or other bacterial viral type elements in the building. So that absolutely speaks to occupant safety, right? Structural durability. Right, if moisture starts to get in and building materials start to degrade, roofing materials, substructural materials, right? So we want to make sure we keep our eyes on that. Occupant comfort.
Yeah,
right?
Even the facade. I just want to step in on here and say even the facade, Troy, efflorescence at the top of a building or brick spalling because of stack pressures or chimney effect happening. Yes, most definitely. Structural durability is one of the parts of the system. Yes.
Yeah, occupant comfort, and then as we said a little bit ago, energy efficiency. So understanding the relationship is really going to be the key to taking corrective action at the right time to be out in front of any issues that these two areas of the building, if they're out of balance, to be in front of it and to be able to correct it as these issues or potential issues are discovered. And so again, obviously if there's air leakage in a building, there's a number of things that can happen. And so Steve, take us through a few of these.
Yeah,
obviously you're seeing some mold and stuff, but
exactly. And for lots of other stuff happening. And the fact is, if the building envelope's leaky, and this picture here you're seeing, this could be at the top of the building, and we find at the top of the building the roof wall intersection is quite open, and you can get reverse stack pressures pulling in warm moist air and causing mold like this to happen, or even bringing in outside pollutants that we see quite often is being pulled in. So yes, most definitely.
Yeah, when we look at a term like precipitation here, we're talking about possibly like a leaky roof, right? We're talking about water intrusion that's coming into the building, which is what, as you alluded to earlier, the facade, the roof, these buildings need to be buttoned up so that water isn't intruding into the building, or even bioburden. And this can be anything from pollens, particles, any kind of exterior pollution that's being pulled into the building. Or even like we alluded to earlier, building materials that start to break down, insulation, things like this can be spread throughout the occupiable spaces because of air leaks in the building and depending on how the building is pressurized. And again, the same thing, poor indoor temperature or humidity control, right? So heat loss in cooler seasons when you're trying to heat the building, or heat gain in warmer seasons or climates, when you're trying to cool the building. And of course, as we know, if there's condensation, moisture, and any kind of temperature swings or instability, that's when we start to see, microbial concerns like the mold in this picture, bacteria, and such. And so as we continue to just kind of, quickly give an overview of how these two areas are connected and then how they start to interact, we want to understand, where does the air come from? Like, where does it leak from? And Steve, maybe you can take the building envelope part out. I can talk a little bit about the HVAC.
Sounds great, Troy. Yeah, well, most of the time, and basically we find that the roof wall is one of the leakiest parts in a building. In fact, the definition of flashing is to hide the fact that the bricklayer and the roofer never met, because we find that as we find that as one of the largest gaps in the building. As an air seal contractor, if I know I can get at a roof wall intersection, I know I'm going to improve comfort and reduce indoor air quality issues, or part of indoor air quality issues, by stopping, bringing in pollutants out and moisture and whatnot. We also have parapets, which are at the top of the building, and in fact, we find that because maybe the building's overpressurized, the pressure is actually going up through the parapets, through sidewalls, and the membranes are bowing out. The building owner thinking, hey, it's the adhesion on the on the roof that's given away, and in fact, most of the time we find it's because of the building being overpressurized, and one of the fixes is to seal, at the roof level before that air gets into the parapet. And then lower level soffits, and if you have a chance to take a look at that little smoke video test in there, you'll see where smoke is being pumped up above a drop ceiling at a soffit. Now there is an air barrier there, or some sort of an air barrier, but it's not sealed totally, so air is leaking through. Now air will come in through wind pressures, stack pressures, reverse stack pressures, and even mechanical pressures. So cladding system intersections, internal pathways too, and we have a few slides coming up showing you stack pressures and how it's so important to try to decouple floor to floor to reduce those stack pressures. If you can do that, you can actually save money, and it becomes a smoke fire safety issue as well by decoupling floor to floor.
Yeah, no, absolutely. In so far as the HVAC system, right, you could almost think of these cabinets, these ductwork systems as being like, mini buildings in a sense, right? So the air handler unit is a cabinet, and it should be sealed properly, where all of the ducting comes into it. So the supply and return plenum ductwork, doors, any kind of hood vents, any of that kind of thing, filter racks, right? So when you put the filters in to filter the air that's returning or the outside air that's being brought in, if those filter racks aren't tight, air can infiltrate around it and get into the cabinet or get into the coils of the air handler unit. And then, of course, any kind of inline equipment that are little, miniature blower fans or reheat coils that are in the ductwork as well. Because this HVAC system is a pressurized system to move air quickly through the building, it can create, if there's leakage in the ductwork, for example, supply air ductwork, if the building's not tight, any constituents that are coming in through air leaks from the building might actually also infiltrate the supply air ductwork and be distributed through the building more quickly or to certain areas of the building. And so it's critical that when we look at a macro level, we're talking about sealing the entire building and everything Steve just talked about. And then sort of as we zoom in, we want to make sure that this air handling system, the HVAC system, is also buttoned up so that it's not creating additional problems or becoming fouled because maybe there's a leak in the building, and now those pollutants and contaminants are getting inside of the equipment. So then when we talk about looking at where the what the conditions for an air leak are, we sort of said where you might see them commonly, right? But what are we talking about when we talk about a leak, right? So things like a hole in the roof, obviously that makes a lot of sense, but I'm sure that there's areas that might pass a visual inspection that you don't even know about because they're tiny or not totally sealed up. Why don't you talk to us a little bit about that? And you can see there's a technical diagram here specific to the air barrier and where it might be in a building.
Yeah, and like you say, Troy, like some of these air leakage gaps, cracks, and holes you don't necessarily see. So for instance, you reference this diagram here, and the cavity insulation, the purple arrow going through actually shows air can travel through the cavity wall insulation, and in this case, into the plenum space in this building here, or through the exterior sheathing, or this is actually showing a drip plane or an equalized pressure plane. So air is traveling through that and into the equalized pressure or into the plenum space above. And then the roof assembly, in this case here, it's showing a metal fluted deck, and that shouldn't be used as the air barrier because it's riddled with holes and seams. So as most air seal contractors try to do is they try to join, you know, the roof to the wall, and in some cases it's using like foam sealants pumped into the outside flute to you know, get to the membrane above, and then the brick wall to the fluted deck to create that air barrier continuity sort of thing. So like I said, this is one of the major items in a building where we find air leakage is working actually in all seasons, and you get stack, reverse stack and positive stack pressures as well. And air pressure differences, some buildings are running under a negative pressure when they're, and what's happening is through the roof wall is pulling in that warm moist air and pollutants and whatnot. So there are three principal types. We have wind stack and mechanical effect. So the next diagram actually shows wind pressure. Now we're showing these arrows are blue, so cold air, just easier to reference. Wind pressure on one side of the building, it actually swirls around the building, causing what you call eddy currents, sucking that conditioned air out of the building on the opposite side. And the suction effect can be 10 times of what the windward effect is. And of course, the taller the building, the more. And this actually can account up to 25% of the total air leakage in a building right off the bat. It can't be controlled unless, you know, the sides of that building are sealed. And it's by finding and fixing the leaks that we can, you know, reduce this effect.
Yeah, in other words, the wind is very hard to control, but we can control the effect that the wind has on the building.
Right,
so,
exactly.
Yeah, exactly right. That makes sense.
Yeah.
And now this is one that it on the surface it makes sense to me. And again, I'm not a building engineer, you know, and so I understand it, but sometimes I think I get a little confused by it as far as like where this pressure plane is and what have you, and then the different things that can also be affected by stack, or what sometimes people call chimney effect. Why don't you take us through this, Steve?
Yeah,
and help me out too.
Exactly, and Troy, and it all depends on the height of the building as well. You know, how many stories are the building? The taller the building, the greater the stack pressures. The greater the temperature from inside to the outside, the greater the stack pressures. Now, in the north, you know, in the winter you get the cold. So as we're showing here, cold air gets in, it gets warm, buoyant, travels up through the top. Now, the neutral pressure plane is usually sitting in around, or it floats back and forth around the center of the building, and that's where the infiltrating air changes to exfiltrating air. Now, the more holes you have at the top of the building, and this could be happening in your house as well, the more holes you have at the top, the greater the stack pressures. The greater the temperatures from inside to the outside, the greater the stack pressures. So there's a bunch of variables that do affect stack effect, or chimney effect, we call it. And then when we start to cool our buildings, or when we're down south, we have reverse stack pressure. So we know cold air, you know, cooled air in a building is heavier. It actually pulls in the warm moist air at the top of the building. And as we know, as soon as it starts pulling it in, it starts to form, you know, condensation. And that's where we see bowing ceiling tiles and stuff like that. And it's a rapid increase of pulling in, you know, pollutants from outside, dirt, bugs, insects, all that kind of stuff. So
yeah, okay, you know, that makes sense. And I think this is where the sort of the rubber meets the road, as the old term goes, as far as how the HVAC or mechanical systems can affect the building in two different ways, right? So depending on how the HVAC system is being used with the building automation system, how it's being controlled, the condition of the HVAC system, right? Is it overpowered? In other words, are they trying to create extra pressure because of certain things that are happening in the building, or maybe the HVAC system is fouled and the airflow isn't what it should be coming out of the HVAC system. So it can have two different effects on the building. So, why don't you go ahead and just sort of set this up, and then we'll look at both the negative pressure effect and the positive pressure effect.
Positive. So here we're showing negative pressure, and what's happening here is in this building, we're exhausting so much, and because we're exhausting so much, and maybe because the makeup air, like you said, Troy, the system is fouled and whatnot, so you're not getting the full pressure that you should. So the negative pressure is taking over, and what's happening is you're pulling in from all sides of the building. So you're pulling in through all the gaps, cracks, and holes. And not only are you pulling in outside unconditioned air, but you're pulling in other pollutants as well. Now, as you can see, the dotted line or the neutral pressure planes up to the top of the building. So you pulled it right up to the top, and you're pulling in from all sides. And again, it happens in taller buildings, or even in your home. If you're running your bathroom fans, 3 bathrooms in there, and your fans are running like crazy, you could create that negative pressure very easily. So
that's like if yeah, so it's like if I'm going up to a building, a shopping center, or even a commercial office building, and I go to try to open that door, there's a suction. Yes. I can't get it open because it's taking it all in.
Yes.
Yeah. Okay.
Definitely. And we see that quite often. Yes. Yeah.
And then for the positive side, when we're talking about positive pressure that is being created by the mechanical system, is this sort of operating in reverse? The actual mechanical system isn't creating enough static pressure or airflow, therefore more air can be brought in from the top of the building, or is there something different going on here?
Well, what's happening here is the mechanical system is maybe overpressurized, or the positive pressure. Maybe we find a lot of mechanical contractors try to overcome stack pressures mechanically, and what they do is they set the pressure so high, and in this case, they move the neutral pressure plane down to the bottom of the building, and all that air that it's costing to heat and cool is expelling through the gaps, cracks, and holes. So either way, this is not cost effective. Now we want slight positive, or even running the building under neutral. Now it depends on certain areas in the building. You may be running, infectious control areas or clean rooms under, different pressures or whatever. But I'm talking about the whole building here. I mean, how many of you actually have walked up to a building and the front doors are flying open?
There you go. Right.
Yeah. Here, we have the opposite effect, as you mentioned, about the suction effect. Now the doors are flying open. Welcome, come on in. Enjoy all this air. I'm heating and cooling it at my cost. So
right,
anyways,
right.
So yeah. So either way, it's not cost effective.
Yeah, that makes perfect sense to me. And so that's why this thing really becomes a collaboration, where all the stakeholders that are in charge of facility maintenance, of building operations, need to be in alignment when we start talking about making sure the envelope is sealed up and tight, making sure that the controls for the mechanical systems are programmed, not only just, for correct ventilation rates, but that the actual systems are working as designed. And so, from your side, why don't you take us through a little bit, like what architects, mainly the folks that are in charge of the building need to think about as far as the envelope is concerned, and then I'll follow up with the HVAC stuff.
Yeah, and again, I always say our motto is seal tight, vent right, and we also find, finally, I've been in the industry over 30 years, and I still, are getting called to buildings that are leaky that were built a year ago. There's still issues, but they've come a long way. We are building tighter. We're recognizing with, ASHRAE codes and whatnot to make sure that we do provide, proper air mechanically. Don't allow on the gaps, cracks, and holes that lead in and out of the building envelope for your vent right aspect of it, sort of thing. And I always turn and say, when I'm talking with a bunch of people, is what's an unhealthy building? A building that's too tight or too loose? you know, and it's kind of a trick question because they're both unhealthy, right?
Yeah.
You know, a leaky building, you're pulling in outside pollutants, dust, dirt, whatever. And then a tight building that doesn't have proper ventilation, you're holding in pollutants and can cause moisture issues and whatnot, depending, you know, how the building is run and whatnot. So,
Right.
and you know what, the key thing is building, we look at buildings as a systems approach. I know we're mentioning systems as the HVAC, but it's a systems approach. And
Yeah.
by doing one thing to the building, you could actually, you know, cause issues at another part of the building. So it's a system. That's all.
Yeah, that makes you know, it makes perfect sense to me. Again, as I kind of said earlier, you know, you sort of have this macro approach of the whole building, and then you keep zooming in and zooming into these sort of individual systems that also have their impacts. And I often say that it can create a chain reaction or a domino effect. So, you know, if something is overcompensated in one area, it's going to create another issue or concern, you know, another area of the building. And so when we start to talk about that, you know, we're really talking about a balance, right, between all of the components of this much larger building system. You know, for the HVAC's part, I mean, obviously, and you know, folks that are on today that are customers or colleagues, you know, you hear us talk about this all the time, but you know, the HVAC system really needs to be clean and properly maintained at all times. You know, and we understand that, you know, certain types of facilities come under deferred maintenance programs, maybe more regularly or more routinely than others, but really you need to be looking at this stuff on the regular basis. And so organizations like ASHRAE, you know, the American Society of Heating, Refrigeration and Air Conditioning Engineers, NADCA, National Air Duct Cleaners Association, these non-governmental organizations provide very clear guidance that is regularly met on and updated depending on, you know, new information, new technology, new situations. You know, obviously coming out of the COVID-19 pandemic, you saw ASHRAE jump into action almost immediately with the CDC, National Institutes of Health, to really sort of go back and look at ventilation rates, what needed to happen for buildings. And of course, we could spend a whole webinar or workshop just on some of the cause and effect of that, right, Steve? Bringing in massive amounts of outside air and flushing buildings entirely, higher ventilation rates on across the board, right? But regardless, you know, on the ops side, and if you're over mechanical, you really should be following this guidance, not only for the ventilation piece, but for the maintenance piece, the operations and maintenance manual piece. And then, of course, yeah, like as we were saying, the building and the systems must be in balance. And, you know, typically, you know, you're going to test and balance a building when it's a new building, right? And you're going to start to certify it for occupancy. A lot of other times that you see the test and balance piece come in is if there was a major renovation, a major tie into a building, a hospital adds a new wing on, and now they want to come and make sure that this new area that they added onto the building is balanced with the rest of the building. And then still another case you might see is if your building is trying to meet a standard like LEED, you know, or the well building standard, and you've done some upgrades or you're retrofitting, then you might retro commission the building as well, where you're testing and balancing the mechanical systems and the building as a whole. So it's not, you know, T&B isn't necessarily routine, but you should be aware of it and take a look at it. Or maybe if there's a major issue, right? Like again, you're rebuilding after like a restoration situation, a hurricane came through and took your roof off, you put a new roof on, you cleaned up some mechanical systems or replaced some, you know. So again, like being able to retro commission the building to certify it safe for occupancy. And then, you know, once this all comes into balance, then, you know, it's very provable that it provides energy cost reduction. And, you know, and insofar as, you know, once, like Steve said, you know, you don't want to be too tight, you don't want to be too loose, but once you can bring that into balance, you can really see some of the savings here. And these are just some snapshots. You know, again, our time is limited today, so, you know, we weren't going to do, you know, an energy efficiency workshop, although maybe in the future we should. But as you can see, there's some good savings here. Just by sealing the roof and wall joint, right? In this single story school campus, 17% savings. Perimeter ceiling in high-rise apartments, 10% savings. You know, we had done some AHU coil cleaning across a few buildings at this Ivy League campus, right? And we saw an average 30% improvement in static pressure. So, you know, the machines were now working more efficiently, which, you know, is going to lead to greater savings. They're not working longer to achieve the same set point because of the fouling and the building was out of balance, right? Cleaning a 650 room resort hotel, little chilled water fan coil unit saw a 2-year payback, a 1.25-year payback. On cleaning 30 units in an urban hospital that had never been cleaned in 20 years. So you can start to see where if you're keeping these systems tight, sealed up, and clean, then you're also keeping your energy costs in check. And I think that that's a really great side piece that in some cases, without doing a full survey, you can see quick payback on doing very little, really. I mean, it's almost services that pay for themselves.
And
So
Troy,
when we start, oh yeah, go ahead.
Sorry, Troy, I was just going to say, as we know, energy isn't going to go down. So, you know, like now's the time to react to get that building sealed and that HVAC equipment running, you know, optimum. Start saving now. So anyways.
Yeah, that's true. And again, I think that, you know, that might be a topic that we revisit here pretty soon, Steve, is looking at this, you know, carbon-free building or zero carbon buildings that we're trying to get to now. A lot of the new era of sustainability and not just, you know, greener energy solutions, but how do you make your building more sustainable? And this certainly is one way, is to make sure that you're keeping an eye on this stuff, cleaning it, maintaining it, keeping it sealed up is going to ultimately lead to being more sustainable. And so, you know, when we start to really dive in here at the bottom half of the workshop, you know, we want to know how to improve this stuff, right? So, you know, now we know what to look for and like the areas that we want to look at. So now let's sort of shift it and think about like, well, how do we want to go about improving this? You know, and how, you know, again, it's, you know, the age-old, you know, idiom, you know, how do you eat an elephant? Well, in bite-sized chunks, right? So, you know, a school system, even a hospital, right? If you look at extremes, a type of facilities where, you know, a school system, public school system is going to rely on, you know, levies and public funds to be able to maintain and improve their buildings, whereas a hospital, you know, you would think if it's a private healthcare system that they're going to be flush with cash and be able to, but it's still a capital expenditure budget that they have to look out 3 to 5 years and be able to look at all of these assets and make a sensible plan to do it. Because as I've often said, Steve, if you're a hospital and you have 35 air handler units, there's no silver bullet or a magic spell where you just go, hey, we're just going to shut down and replace 35 air handler units. I mean, one, logistically, it would never happen. Two, even if you were the wealthiest or highest performing healthcare system in the country, you're not going to put that kind of capital out at one time. So how do you really improve this stuff, whether it's the HVAC or the building? Well, first, you have to be able to measure what you're managing, right? So you have to have the data. You have to have the optics and the visibility into what's actually happening inside of the building, inside of these air handler units, the ductwork, and then based on that data, follow it. Follow the recommendations that it's going to provide to you, right? So, you know, in many cases, the numbers don't lie, photographs don't lie. And so if you're not looking at this stuff regularly, chances are you're going to start to have lots of problems down the road that could create, you know, big maintenance expenses or bigger capital expenses. So you want to be on top of this stuff all of the time. And luckily, again, speaking of ASHRAE, you know, there's guidance for us to do this, right? So ASHRAE 62.1, we talked a lot about this because it is literally the standard for calculating ventilation in buildings for good indoor air quality. right? And so there's a lot of high-level engineering stuff in there. There's a lot of formulas and calculations depending on the type of building, size, type, use, age, things like that, the type of equipment. But really, there's one section in this standard, section 8, that talks about operations and maintenance of this equipment. And so if you look through there and what they're recommending, 27 areas of this section 8 deal with inspection and cleanliness of air handler units and these air conveyance systems, right? So if you're looking at that, or having an outside firm like WTI Pure Air come in and look at this stuff, a report then can be made, and that can be built into a larger asset management plan that will really start to grade out this equipment and tell you what corrective action that you need to take. And in many cases, you don't have to replace equipment. There will be some repairs that you would need to make, but really you could restore the equipment or retrofit it with more modern technology. So when we start to look at an equipment or system assessment, what are the things that you're looking for when you're coming through and you're assessing or taking a survey of your mechanical schedule? Well, one, the physical conditions. I mean, you can see if you're on a roof and the galvanized metal is rusting and it's staining the roof, well then, yeah, you probably need to paint it, right? If there's holes in it, I mean, you're going to be able to physically see some things. Obviously, you're going to want to lock it out, tag it out, and then we can look inside of it to see what the conditions of the coil, the drain pan, any kind of component parts are, take photographs and start to document the actual conditions, based on the make, model, serial number of each one of the air handlers in the schedule, right? Then what we start to look at is performance of the systems. Is it holding static? What does the thermal transfer off of the coils look like? Is it degraded? Is it being able to operate as designed? Is there leakage? As we discussed earlier, are the doors sealed? Are the plenums sealed, correctly? And then again, really when we talk about performance testing, if major work was done on the unit, or maybe new units were introduced or ductwork was rerouted, then we start looking at maybe bringing in more of a NEBB like test and balance crew that needs to make sure that these new units are balanced with the old units, something like that. But mainly for an HVAC conditions assessment, we're not going to go to the extreme of like what a T&B person would do.
Right.
And then finally, it would be environmental, right? Like we'd want to pull samples out of the supply and return plenum, off of the filter racks, pull samples out of the drain pan, and off of the coil and be in blower, and be able to send these to an environmental laboratory to assess what kind of stuff might be in there that could cause some serious concerns within the building. And again, this could be anything from microbial concerns to particulates to man-made fibers such as fiberglass that is on the supply side and could be distributed to where people could breathe it, right? So we're looking at all of these things when we're conducting this type of assessment. And typically you would want this in a comprehensive report with recommendations to be able to start to make that 3-5 year plan to start to take that corrective action. And when we look at the corrective action, what are we talking about? We're talking about routine maintenance, being inside of these units, being able to change the filters regularly, make sure the blowers are operating properly, that the belts are at the right tension, that the bearings are greased, that you're doing regular tune-ups, so the blower is not cavitating, so the belt's not shedding rubber that could get into the coil or even downstream, right? And then further, being able to clean these units up, right? To be able to clean not only the coils to restore airflow through them, but also the drain pan, the component parts, and then everything that air handler unit is hooked up to, all of the ductwork and such, including inline equipment, VAV, terminal boxes, reheat coils, that kind of thing. So in this picture, you're seeing a pretty large, chilled water evaporator coil. And you can see the kind of fouling that can get on this coil if you're not inspecting it routinely or cleaning it routinely. And so this kind of buildup on a coil not only, Steve, restricts airflow, as you know, but it's going to insulate that coil. And when that coil is insulated, it's like putting a wet blanket over it, right? So now this machines don't work harder. They're not a person, as much as ChatGPT would like you to think it's a person when you're asking it questions.
Right.
It's not a person. It doesn't work harder or less. It just works longer, right?
Right.
And so if you're working longer to achieve the thermal set point that you want, you're going to expend more energy doing so. So that's
So
why
what,
it's important to keep these things clean, the airflow moving through them, and having them operating as designed. This stuff
so
that you see on the, yeah, go ahead, go ahead.
just a question, Troy. So with a coil this clogged, what type of reduction in energy, like, would we see in this? Like, obviously, it would reduce, or it would reduce the energy efficiency factor of this.
Oh yeah. So the EPA has done independent studies that you can look up, and
Mm-hmm.
basically what they're showing is about 3/16 of an inch of fouling. So
Mm-hmm.
maybe just the width of a business card or a
Wow.
little bit more, right?
Yep.
It's going to drop it by 21%.
Wow. That's
So,
good.
and the other factor to consider here is that what you're seeing here is a buildup of dirt, debris, and dust. Dust in a building is mostly made of human skin cells that have been shed.
Mm-hmm.
It's biological material. And so what happens is when it's damp and bacteria comes in from other leaks inside of the building, inside of the cabinet, the bacteria starts to eat this stuff, and the excrement from the bacteria allows mold to come in and start to grow.
Mm-hmm.
And so we were talking about cause and effect. We were talking about a chain reaction. This is the kind of stuff that can happen, or if this is in a drain pan and what have you. So when we talk about cleaning the coil, you want to use high temperature and low pressure, but not too low, like a steam system that's going to steam and drop all of this fouling off and out of the interior of this coil. So a common way to clean these coils is going to be to throw some sort of chemical solution or even an eco-friendly cleaning solution on it, and then
Mm-hmm.
hook a hose up to the utility sink that's right outside of this air handler unit and just hose it off. Well, the pressure coming out of, your regular plumbing in a building is going to be about 60 psi. And so you don't want to pressure wash it because these coil fins are pretty delicate, but you want to have a significant amount of pressure and temperature to be able to drop the fouling out and to be able to sanitize it at a high temperature, 350 degrees, 350, 400 psi with properly trained technicians will not only get it off of the surface, but get it out of maybe an 8-inch thick coil so that you can restore airflow and sanitize the entire system. And then, of course, when we talk about restoration and retrofitting a system, well, now we're talking about actually making repairs that make sense. We're talking about refinishing any of the metal coatings, so sanding it down, sandblasting it, priming it, and painting it with high performance coatings that are flexible, that are antimicrobial, that are gonna last. Many brand new units come right from the factory, the OEM, and it's just galvanized metal, where there might be a thin layer of paint on it. So we're talking about high performance flexible coatings, the kind that would be on oil derrick rigs out in the out in the ocean or in the desert, right? We're talking about flexible coatings that can withstand the rigors of this kind of mechanical equipment, temperature changes, UV conditions on a roof, for example. And then we're talking about upgrading components, right? So the metal box, the technology of an air handler unit hasn't changed all that much, a chilled water unit in 60 years, right? So if the bones of this thing are good, you can make some minor improvements, clean the coil up, paint it, maybe add this new technology like a fan array using multiple fans instead of one big AC motor blower with a belt, and be able to have essentially a modern system that has a new warranty, new fiberglass, it's not fiber, or new fiberglass free insulation, it's not fiberglass, and have basically essentially a brand new unit. All done in place. So again, we're talking sustainability here. You're not, trucking an old unit out of a mechanical room or off of a roof, trucking a new unit in, setting up temporary cooling. You're staging this work out and you're doing it over the course of a few nights. And you're saving a lot of time, a lot of money, and a lot of breaking down or recycling of old materials. So when we talk about the HVAC system, test, don't guess, take the data and do what the data says, get it cleaned up, restore the areas you can, and then bring it back into balance. Now, when we talk about the building envelope, Steve, this is your area of expertise. And so we're going to kind of go through these 5 critical areas to be able to test and seal. But why don't you talk a little bit about that? I'm sure it's not all that different than what I was just talking about.
No, not really. You know, we do test and balance to a certain point. You know, as we're walking through the building, gathering data, but, you know, doing the envelope assessment. Now, the envelope assessment's done from the inside. We use the inside as the air barrier. So we can tie the components together to create an air barrier. And environmental assessment, well, that's all done with the envelope to determine what is going on in the building. You know, bringing outside pollutants or bringing outside warm air that's causing moisture, you know, that's, or even birds or bugs, you know, getting into the building. So, and the 5 critical areas that we're testing is, you know, the top of the building. That's where your stack pressures are the greatest. So that's one of the first things, you know, walk roofs, then get inside, walk each floor. We also look at the bottom of the building, and that could be the soffit or the ground floor and anything below. And as I mentioned in, you know, the stack pressure, we like to decouple each floors if they're independent from one another. So we look at vertical shafts that connect floor to floor. By actually sealing those areas up, we can reduce stack pressures, save money by doing that, but we can also make the building a lot healthier and safer as well. By sealing floor to floor, you can make the building, you know, smoke and fire safety much better that way. And then outside walls and openings, you know, like windows and doors sort of thing. We find that windows, when tested with our little window tester, are 4 to 6 times leakier than the AMA standard for tightness in windows. And the nice thing is, through surface sealing with weather strips and caulks and, you know, products like that, we can bring the tightness up of that window up to the standard. So, and then when you get into rooms that are vented part-time or full-time, you know, shipping rooms, you know, HVAC mechanical rooms where there's a 4x4 grill on the side of the wall, and the grill opens when the appliance calls for air, but yet the doorway leading into the conditioned space isn't weather stripped, and you have duct and pipe penetrations. You want to treat that pretty well if it's, you know, outside the envelope, depending on geographical location. There is a few things that we determine that we will tie some of the mechanical rooms within the conditioned space. It all depends, but that's a side note. And by, you know, doing the building envelope assessment, we're walking around, as you can see, the top left picture there is an air leakage detector. This actually, when you puff it, it reacts, the chemical reacts with the moisture in the air, and it actually shows the air going in and out. We call it a smoke pencil. We also use infrared, thermography. Now the picture here, we're showing the whole facade, but a lot of the times we're using the IR camera at the measure we're looking at. So for instance, from the inside of the building, we move a drop ceiling tile and we look at the roof to wall intersection. Also on the top right is, you know, large fans. There are several manufacturers in the US. This one here is showing a company called Infotech, and that company produces a 50, 60, and 70,000 CFM fan to create that pressure difference. Now, because we have stack window mechanical and we have the smoke pencil, a lot of the times we don't need a fan. The only time we seem to use a fan is if the client wants to get numbers on how you know the building is, what size the hole is in the building, sort of thing. But most of the time it's walking around with smoke pencil and IR camera. And then from there, all of this data is put into our software, and it actually puts out the size of hole that's going to be air sealed, the CFM of air or liters per second of air that's leaking in and out of that hole, and what type of reduction and what type of reduction in energy. Now, just to let you know, today we still find energy doesn't really drive our industry. It's comfort. Too hot, too cold, too wet, too dry, or bugs or irritants that are getting into the building that are driving people crazy, sort of thing. But we find energy efficiency as a justification. As energy goes up, I'm sure that will change.
Yeah, absolutely. And so when we look through these 5 critical areas. And I know, some of the stuff we've pretty much covered along the way here.
Yes. Yeah.
But again, just to give our folks in attendance today an idea, we're going to look at some diagrams and just some key areas that you want to keep your eyes on, or what basically an envelope assessment is going to take into account, and then probably give you corrective data action to be able to go and address these certain areas. So why don't you sort of quickly take us through this, Steve, and,
Sure.
I'll advance the slide because we have the diagram, and then we show you some examples here.
Awesome. So, roof wall intersection, as I said earlier, is one of the top areas. Being owned by a roofing company, all of the roofer reps are actually looking at roof wall intersection for any new, roof or restoration of roof, and we're quite busy, sealing roof to walls, mechanical penthouse door. I mean, all these items at the top of the building where pressures are the greatest should be looked at. So the top left picture there, this is a roof exhaust. When we flipped it back, we were looking at drop ceiling. So all of a sudden now we have an 8 square foot hole on top of this, chimney we call a building basically. But normally the designer brings the roof up to the curb, and the mechanical contractor drops in his ducting and leaves a 2-inch gap. Now sometimes it's flashed over, but it's never sealed. So you get enough of those at the top of the building, it's a huge hole just at the top where stack pressures are the greatest. The next picture over it, remember I mentioned about, foaming into the flute. So, 1/4-inch hole, he's pumping in a 2-part closed cell polyurethane foam. We want it to get to the membrane above and travel to the flashing, and then he's going to spray the block wall to the fluted deck to create that air barrier continuity. Picture on the bottom right is actually inside from a soffit. And I don't know if you can see in the picture, but the ceiling tiles are bowing. Good indication of moisture loaded ceiling. Sometimes it's from roof leaks, but other times it's pulling in moisture. So that's an open soffit. And then an underground parking area. And you can see the dirt pulling from the underground all the way in through the building. And in fact, this building had dirt 5 and 6 stories up.
Yeah, right there. Wow.
Yeah,
Again, you can visually see some of this stuff, which will give you the clue to then peel back the layer and say, okay, this is where we need to focus.
Exactly. And then vertical shafts, any shaft that connects floor to floor. We have a whole line of items here. I won't go through them one by one, but stairwell fire doors, fire hose cabinets are plumbed. What happens is on each floor, it just keeps pulling the air up through. Here's a gas pipe on the bottom left one, the top left one. The top right one is actually an electrical closet, and you can see they shoved in a filter material to filter the air on the way up to the next mechanical room, I guess, sort of thing. And then, and then the picture on the right, the seals have shrunk, and we see this in fixed units all the time. So here's another hole in the envelope where you're pulling in, pollutants and unconditioned air, or pushing out your conditioned air. And if you're in an area where you have baseboard heaters, again, this is another air leakage point. So, and then outside, anything that has to do with the outside walls. And typically doors, every door that I look at is pretty well leaky. It isn't weather stripped properly. So there is, there's hope. There's hope out there. So
yeah, again, for our viewers today, there's a handout tray, and in that handout tray, Steve passed over a video to me. It's just 2 minutes long. But it shows an entire building being tested by pumping theatrical smoke through the building. And I can attest to that. All those doors were it was blasting smoke out of the front doors and some of the windows. So yeah, I imagine that could be a problem. And if you think about it, inside of a building, it's one of the most heavily used access points to the building. People are constantly coming in and out. So I imagine that's an area you would want to look at, quite frequently to make sure your weatherproofing, and mitigation strategy is up to date.
Yeah, and Troy, that front door becomes kind of a maintenance issue sort of thing because it has so much action and open and close sort of thing. So yes. Yeah. I mean, there's high performance seals that are used to last longer. And also, there's a system to replace just the foam seal itself. Okay. So you're not taking the whole holder off and doing, anyways. But then compartmentalization, we spoke about that. We have a whole list here too, not limited to these as well, but you know, I mentioned about the vented mechanical rooms. Any room that's vented part-time or full-time should be compartmentalized. So,
Yeah,
and
so you
so
need to
we're,
be.
yeah, workshop, you know, your mechanical room there, high voltage room, you know, a shipping dock, you know, shipping dock in a hospital, the hospital that I assess, 3 doors at the back. They leave them open all the time. Trucks back in, unload the goods. They have several double doors. Those aren't weather stripped. They have duct pipe penetrations that are leading into the conditioned space. So what's happening? It's pulling all the pollutants and dirt off the roadway right through the whole building. So very not healthy and not energy efficient as well.
Yeah, no,
Yeah,
certainly not, especially for a
exactly.
hospital. Yeah, so
Exactly.
I think that, you know, in conclusion today, and we appreciate everyone stopping in, and we've had a few questions. Yes, the slide deck is available in our handout tray, as well as the video I just referenced. We appreciate everyone stopping by today. I think just in conclusion, you can see that both of these systems, the envelope system and all of the components, these 5 major components or areas that we just covered, and then the air handler units and the HVAC system itself, they have to work together. It's a must. They have to work together to create a safe and healthy and comfortable environment for the building occupants. And so I just think that this is an area that maybe doesn't get talked about a lot, or that gets talked about independently. And
Yes.
so, you know, Steve, I thank you for coming on today to help tie it together and bring it all together. Is there anything that you want to say in conclusion, and then we'll get to some questions and answers?
No, I just want to thank everybody for the opportunity, and you know, our contact information is up here, and we welcome any questions or comments, and send pictures of issues that you have in your building, and you know, we certainly love to help.
Yeah, absolutely. So once again, on behalf of Steve and myself, thanks for attending this IAQ Matters online workshop, Tighten Up, the HVAC and building envelope connection. Thank you. So
Thank you.
let's go ahead and open it up for some questions here. And I have a couple thank yous. Thank you, Angelica. And yep, certainly, Darnell, you know, you can pick up the deck right here as a download, and we will be sending out an email that will have a YouTube link to the replay of this entire workshop. So yeah, you'll be getting that. We have a question, Steve, from Ian Haddon, and he says, I would appreciate knowing what smoke pens you have found to be the most helpful, and then also what training do your teams undergo to utilize and understand the thermal imaging cameras?
Oh, okay. Okay, so first question, the smoke pencil. Unfortunately, the manufacturer of the smoke pencils that I showed in the picture here in the presentation no longer manufactures them. So we actually bought all of their stock, and we have years and years, probably 100 years worth of smoke pencils at this point. But that same manufacturer has come up with an electronic one that works with glycol and a little fan system and whatnot. That's called RetroTech. But there's also others that you can buy in the market called, I think it's called the Dragon, and a few others. You can just Google, you know, testing buildings with smoke, or now it may show theatrical smoke, but there are manufacturers out there that do have these smoke pencils. There's also ones that that puff out a little bit of a silica, and they're like a bottle that you could go up to, and make sure whatever smoke one you're using is to go 90 degrees up to where you think the air is going in and out. In our case, with ours, we give it a slight squeeze, and the turbulence of the air will pull it in, push it back. Now, getting back to the second question, the IR, all of our assessors are BPI certified. That's a third-party accreditation out of New York State. Actually, they're right across the US now, but their head office is in just outside Albany, New York. And that is basically houses a system training. And that also includes doing fan testing on a home and whatnot. Now, all of our assessors go one step further besides the BPI training, and they do a big building training with us. Sorry, I digressed a little bit, but the IR, most of our guys are thermography 1 or 2 certified, and they go through another independent third-party IR testing, which is, I think it's about a week long.
No, that was a good question. You know, for our part on the HVAC side, though it wasn't asked, but I'll put it in there. You know, obviously, and maybe Steve would speak to this or agree with this too. Like any of our building scientists that are going to come in and assess the HVAC system, or our mechanical assessors, of course, you know, all of the instrumentation that we use to take static pressure, to look at the various areas of the ductwork and everything is NIST certified or ISO compliant. And of course, all of these guys are either trained up under our mechanical engineers that are in-house, or, you know, obviously carry the proper like NADCA certifications, the NEBB certifications to go with it, to be able to get in and look at this equipment and really take the readings that they need to take and start to assess and put this information together and report on it. I had another question that was focused on some of these areas that we talked about in these 5 critical areas. How easily accessible are some of these areas? Does access have to be created, in other words, to find or seal certain areas that might be disruptive to a building, or is most of it accessible, I guess is what they're saying?
I'd say most of it is accessible because we're using inside, you know, like the outside wall, the inside of the outside wall as our air barrier. So it's mostly all surface sealing. Occasionally we've had to, and Troy, what happens is when you start knocking holes into walls, the cost goes up, and then next thing you know, the client doesn't buy. So, you know, on average, you know, we're seeing paybacks 3 to 10, 3 to 12 year payback sort of thing. When we start to knock holes into walls, then we start getting, you know, 50-year paybacks and whatnot.
Yeah.
So,
yeah, I imagine that unless there was some larger concern in the interstitial cavities, if a pipe burst, or if the roof was able to leak in between and there was a microbial concern or something, then you're going to start to talk about maybe removing wall portions and things like that to be able to go in and remediate those areas and clear them, you know.
So one of the issues and getting at is a roof to wall. Sometimes, you know, sure, in a building we have no problem. Other times there's, you know, ducts running so close up to the, or pipes or conduits, or, you know, fiber optic cables, you name it. I mean, if you're getting your roof restored or a brand new roof on there, that's a great time to get your roof to wall sealed, because that can be sealed from the top of the building as well.
Yeah.
So.
No, yeah, that makes good sense to me. All right, well, folks, we thank all of you for joining us again today. Thank you, Jim. Thank you, Louis. And yeah, we're getting some kudos here, Steve, in the question tray. Again, you know, be sure on your way out to grab any of those handouts that you feel would be helpful. Once you guys and gals get the link to the video, be sure to share it with any of your colleagues that you think would benefit from this information. And then again, I can't stress enough, because I know many of you are valued customers or colleagues. If ever in the future you would like Steve or myself to give this type of presentation to your group, your facility group, your engineering group, or ops group, you know, hit us up. Our contact information is right here. We're happy to schedule, you know, sort of a customized Teams call where we can run this presentation, or if you had something specific in mind, we're definitely here to help and communicate and pass helpful information on to make your buildings more airtight, energy efficient, and comfortable for your occupants, and heck, easier to maintain. Once you have this thing in balance, as long as you keep your eyes on it, it should be a lot easier to maintain and not get so far out of control that you're having to deal with big concerns. So again, on behalf of myself and Steve, thank you. Stay tuned to our LinkedIn's, Canam Building Envelope, WTI Pure Air Control Services, Trimco, Roofing Building Maintenance, Trimco CPG, for future education opportunities. And have a great weekend, everybody.
Thank you.
Thank you.